But did you know that it's voluntary? Like if you tell them, no, I don't want my picture taken, because all over, if you walk through security, there's like signs that says voluntary, and some people don't pick up on it. They just go ahead and do because everybody else is doing the picture. But also that's very dangerous because it keeps up your data throughout the years every time you go through.
100%. I didn't know that. That's good to know.
Yeah, of course.
Very smart.
They only need the picture of your driver's license. That's it.
Okay, so let's look at the TSA side. No, your point's well taken. Suppose you decide you don't want to do that, and the TSA is thinking,
It's kind of cool.
I wonder why.
It's cool, but like I don't.
What do you do for them?
Just curious.
Not to have my picture taken.
You say,
I just think it's intrusive.
no, I know it is, but
Yeah.
the fact is, I'm saying, let's look at it from the
Yeah,
security side.
from the security side.
You'll be listed as non-compliant.
And they give you like a good attitude with it too. Like they're not happy if you're standing in front of them saying, no, I don't want my picture taken. Given there's signs all over the place saying,
Sure.
Planning out travel for
Interesting. I'm going to have to perform an experiment and come
yeah,
fly again.
yeah.
We've had a lot of different.
Oh, I have a list.
You saw the list. You added
I'll show
to
you later.
Yeah.
Well, the undergrads are all over there. We were right on there. You should have been in my first class. The deadhead class.
Was up bright and early this morning. Was up bright and early this morning.
You were. You should have gone into my class.
We have 5 people?
Five. The Fab Five. Okay, since I mentioned a bunch of foundation models, what you've got here, this guy is an Aussie, and he's an IBM fellow. Those are rare individuals who've done enough in their technical side to have patents or all kind of copyrights or something, but they come and go as they please, and they're really, really interesting people. And this guy's one of them. He does at the moment he's doing videos. Ask me questions about foundation models, and I thought you'd get the chance to listen to him.
AI, how do you decide on which foundation model to pick to run it? With the huge number of foundation models out there, it's not an easy question. Different models are trained on different data and have different parameter counts. And picking the wrong model can have severe unwanted impacts, like biases originating from the training data or hallucinations that are just plain wrong. Now, one approach is to just pick the largest, most massive model out there to execute every task. The largest models have huge parameter counts, and they're usually pretty good generalists. But with large models come costs. Costs of compute, costs of complexity, and costs of variability. So often the better approach is to pick the right size model for the specific use case you have. So let me propose to you an AI model selection framework. It has 6 pretty simple stages. Let's take a look at what they are and then give some examples of how this might work. Now, stage 1, that is to clearly articulate your use case. What exactly are you planning to use generative AI for? From there, you'll list some of the model options available to you. Perhaps there are already a subset of foundation models running that you have access to. With a short list of options, you'll next want to identify each model's size, performance, costs, risks, and deployment methods. Next, evaluate those model characteristics for your specific use case. Run some tests. That's the next stage. Testing options based on your previously identified use case and deployment needs. And then finally, choose the option that provides the most value. So let's put this framework to the test. Now, my use case, we're going to say that is a use case for text generation. I need the AI to write personalized emails for my awesome marketing campaign. That's stage 1. Now, my organization is already using 2 foundation models for other things, so I'll evaluate those. First of all, we've got Llama 2, and specifically the Llama 2 70 model. That's a fairly large model, 70 billion parameters, it's from Meta, and it's quite good at some text generation use cases. Then there's also Granite that we have deployed. Granite is a smaller general purpose model, and that's from IBM. And I know there is a 13 billion parameter model that I've heard does quite well with text generation as well. So those are the models I'm going to evaluate, Llama 2 and Granite. Next, we need to evaluate model size, performance, and risks. And a good place to start here is with the model card. The model card might tell us if the model has been trained on data specifically for our purposes. Pre-trained foundation models are fine-tuned for specific use cases, such as sentiment analysis or document summarization, or maybe text generation. And that's important to know because if a model is pre-trained on a use case close to ours, it may perform better when processing our prompts and enable us to use zero-shot prompting to obtain our desired results. And that means we can simply ask the model to perform tasks without having to provide multiple completed examples first. Now, when it comes to evaluating model performance for our use case, we can consider 3 factors. The first factor that we would consider is accuracy. Now, accuracy denotes how close the generated output is to the desired output, and it can be measured objectively and repeatedly by choosing evaluation metrics that are relevant to your use cases. So, for example, if your use case related to text translation, the BLEU, that's the bilingual evaluation understudy benchmark, can be used to indicate the quality of the generated translations. Now, the second factor relates to reliability of the model. Now, that's a function of several factors, actually, such as consistency, explainability, and trustworthiness, as well as how well a model avoids toxicity like hate speech. Reliability comes down to trust, and trust is built through transparency and traceability of the training data, and accuracy and reliability of the output. And then the third factor, that is speed, and specifically saying how quickly does the user get a response to a submitted prompt. Now, speed and accuracy are often a trade-off here. Larger models may be slower, but perhaps deliver a more accurate answer, or then again, maybe the smaller model is faster and has minimal differences in accuracy to the larger model. It really comes down to finding the sweet spot between performance, speed, and cost. A smaller, less expensive model may not offer performance or accuracy metrics on par with an expensive one, but it would still be preferable over the latter if you consider any additional benefits the model might deliver, like lower latency, greater transparency into the model inputs and outputs. The way to find out is to simply select the model that's likely to deliver the desired output and, well, test it. Test that model with your prompts to see if it works, and then assess the model performance and quality of the output using metrics. Now, I mentioned deployment in passing, so a quick word on that as a decision factor. We need to evaluate where and how we want the model and data to be deployed. So let's say that we're leaning towards Llama 2 as our chosen model based on our testing. Right, cool, Llama 2, that's an open source model, and we can inference with it on a public cloud. So we've got a public cloud already out here. It's got our LLM of choice in it, which is Llama 2. We can just inference to that. But if we decide we want to fine-tune the model with our own enterprise data, we might need to deploy it on-prem. So this is where we have our own version of Llama 2, and we are going to provide fine-tuning to it. Now, deploying on-premise gives you greater control and more security benefits compared to a public cloud environment, but it's an expensive proposition, especially when factoring model size and compute power, including the number of GPUs it takes to run a single large language model. Now, everything we've discussed here is tied to a specific use case, but of course it's quite likely that any given organization will have multiple use cases, And as we run through this AI model selection framework, we might find that each use case is better suited to a different foundation model. That's called a multi-model approach. Essentially, not all AI models are the same, and neither are your use cases. And this framework might be just what you need to pair the models and the use cases together to find a winning combination of both.
I put that up here because the default option for all of us, we're talking about large language models, GPT, Anthropic, Gemini, but it's a lot more complicated out in the real world. So that's not a bad step through right there. By the way,
What is inferencing? It's an AI model's time to show.
he has a lot of these, by the way. It's one of those things where you're spending a lot of money on these things, okay, with compute and utilization. They're tricky. We're going to have to talk about generative AI governance. We're totally at sea in academia. We don't do any of this. And so I just wanted to let you know that everything he's talking about there is business professional stuff.
If you have a use case for generative,
You do not in any way have to know what the bilingual evaluation model is. If you're doing translation, you just feed both translations in there. Or you can do this, English to German, check it, then don't do anything else. Just take the German translation and tell it to translate back to English. Sometimes you will get hilarious results. Okay, but do you have to know anything? No, you just feed in the model, it gives you a score. Okay, then it'll highlight the mistakes. My point is, your organizations are all going to be different. You're going to be in different industry verticals. You have different financial and different functional responsibilities inside those verticals, depending on what you do. And so a lot of times you can run tests like this without a problem. Now, you're going to have your analysts and technical people in here to give you guidance on the various foundation models that are out there. You can also hunt them up yourself. As I said, I developed one just to do supply chain management when I was trying to figure out how to develop my own AI tutor. And turns out that you can do that too. I don't recommend it, but you certainly can. Okay, so we're talking about a specific foundation model in healthcare. Now, I will say this is Google's latest. It's called MedPalm, and it is, this is MedPalm 2. It's not an AI doctor, which naturally, anytime you get a marketing person in here, you're going to get that. It is a foundation model for healthcare, and it's quite specific. It is, it's pretty good. They haven't said much about it for a couple of years, so this is their latest.
In all types of industries, including healthcare. This field, which impacts everyone, is quite complicated and filled with data and challenges. So that's why AI will play a very important role in it. AI can support doctors and other medical professionals in improving their decisions and patient care, even saving more lives. Now, Google has been creating and using AI solutions in many areas for a long time. They've also put a lot of money into healthcare AI to enhance health results and make it more accessible for all. One of their most ambitious projects in this domain is MedPalm 2, a new medical AI that they just unveiled at Google I/O 2023. MedPalm 2 is a powerful language model that can understand and generate natural language in the context of medicine. It can also perform reasoning and inference based on medical knowledge. So MedPalm 2 is a special type of AI designed specifically for the medical field. Google's been in AI tech for a while now. They've built top-tier AI models like Google Search, Translate, Photos, Assistant, and Bard.
Hey, Alicia Little here, and I'm excited to announce that the third annual AI and Marketing Summit is here. This is it.
Now, MedPalm 2 is a healthcare-focused version of Palm 2, a giant neural network that learns to use language from billions of words across sources. It also manages code, math, logic, and several languages. But Palm 2 isn't just one model or product. It's a family of models of various sizes and complexities, from the 1 trillion parameter unicorn to the 100 million parameter gecko. It's also a platform adaptable for different purposes and domains, one of which is healthcare. Google understood that healthcare needs specialized knowledge not easily captured by general language models, and it's an area where AI can hugely improve lives. Therefore, they created MedPalm 2, a healthcare-focused version of Palm 2 based on an otter, another model in the Palm 2 family. MedPalm 2 isn't Google's first medical AI. They had MedPalm earlier, based on Palm 1. While impressive, MedPalm had its shortcomings. It was only trained on English data, struggled with complex medical questions, and lacked ethical and social understanding vital for healthcare. That's why they developed MedPalm 2, an improved version of MedPalm, overcoming these issues and adding new capabilities. It's unlike general AI such as Palm 2 or GPT-4, as it's educated on vast, varied medical data from reliable organizations. This AI is honed for specific medical tasks like diagnosing diseases, planning treatments, patient education, and medical research. It improves its precision by learning from medical experts' feedback. It caters to several languages and can translate between them, taking into account cultural and regional nuances. It's also programmed with ethical values, respecting user privacy, and can clarify its decision-making process. Upgraded from MedPalm, the new version processes a wider range of medical data, performs better on medical tasks, supports more languages, and can tackle complex medical inquiries. MedPalm 2 is a standout AI model with several impressive features. It can ace U.S. medical licensing exams, achieving 85.4% on the MedQA dataset from the USMLE, and 72.3% on the International MedMCQA dataset. This AI excels in summarizing medical documents, sifting through large health data, and answering complex medical questions clearly and concisely. So if you ask about any disease symptoms, it can provide a detailed response. Moreover, MedPalm 2 is multilingual and culturally adaptable, capable of translating and responding accurately across languages and dialects. Whether you're asking in Spanish or English with an Indian accent, it delivers precise information. Now let's see how it works in real life and how it benefits people. So this is not just a theoretical model that exists in Google's labs. It is actually being tested and used in real-world settings by real people. One of the places where it is being tested is the Mayo Clinic, one of the most prestigious healthcare institutions in the world. The Mayo Clinic uses MedPalm 2 to help its doctors and medical staff with their work. For example, MedPalm 2 can help doctors with summarizing medical records, finding relevant information from research papers, and answering patient queries. It can also help patients with understanding their conditions, finding reliable sources of health information, and asking questions about their treatments. And it is not only being tested at the Mayo Clinic, but also at other hospitals and healthcare institutions around the world. Google has partnered with various organizations to deploy and evaluate MedPalm 2 in different settings and scenarios. It is being used by the National Institutes of Health, NIH, to support biomedical research and innovation. It is also being used by various universities and medical schools to train and educate future healthcare professionals. It is set to change healthcare significantly. It boosts the quality of services by supplying accurate medical information, helping doctors in their duties, and facilitating communication between all involved parties, like patients and policymakers. Efficiency-wise, it lessens the burden and cost of healthcare delivery, smoothens operational processes by automating tasks, and speeds up the discovery of new treatments by analyzing vast health data. It also enhances accessibility by reaching more people, overcoming language and geographical barriers, and offering scalable solutions. It also encourages people to manage their health by offering customized, interactive experiences. But it's crucial to explore its potential challenges, limitations, and risks. To be honest, this AI isn't a cure-all for healthcare and can't replace doctors. It has limitations, like struggling with rare conditions or personalized treatment suggestions. It might become outdated, inconsistent, or even harmful if misused. But this medical AI is just starting its journey and will keep growing. In the future, Google aims to make it more user-friendly and affordable, while also including more languages and cultures. They plan to boost its accuracy by using more data and getting more feedback. Google also wants to help healthcare firms tailor MedPalm 2 to their needs. Now we find ourselves facing a major concern once more: trust. We must consider whether it's safe to entrust something as crucial as our health to an artificial intelligence model, especially when we're aware that it's backed by a giant profit-making corporation like Google. Can we confidently believe that their intentions are noble? As we understand, every artificial intelligence model is directed and programmed according to the desires of its developer. This implies that we would be depending on Google and any other companies that participate in building these healthcare AI models for our health-related matters. This raises some important questions that we need to address before we embrace these AI models as our medical advisors. How transparent are these models about their sources of information, their methods of reasoning, and their limitations? How do they handle sensitive data such as our medical records, our personal details, and our preferences? How do they ensure that they are not biased or influenced by external factors such as advertisements, sponsors, or political agendas? How do they respect our autonomy and dignity as human beings and not treat us as mere objects of analysis and prediction? These are some of the ethical and social challenges that we need to overcome before we can trust these AI models with our health and well-being. I'd love to hear what you think about this, so please share your before we embrace these AI models as our medical advice, personal details, and our preferences.
Okay. This thing works like a charm. You need to understand, it's really good. We're 2 years further into it than what they're talking about here. The reason I picked on healthcare is because well, first of all, you guys are too young to worry about it. The boomers, however, we're all concerned, and I'm sure some of the people out in TV land have reached my group's level. Not quite. They're in between you and me. Physicians don't stand a chance. You guys should understand. I'm not jumping on them. They do 4 years of undergraduate, give or take, and while business students are sipping cool beverages in the afternoons, what are pre-med students doing? They're in labs, at least 3 days a week. Don't think they don't look at the windows out the windows at you guys. That's the first thing. Then they go to 4 years of medical school. That is 4 years because everybody goes through on the same syllabus. And then they go to hell. And hell is residence. It's not their fault. They work them 100 hours a week, 5 years minimum. Okay, now you can get away with 3 years for family practice, surgery, 5, 6, whatever they require. You might have to do a fellowship, but the point is, it's slave labor, okay? And then they're in their early 30s and they get out to go practice. To give them credit, they work hard. The problem is, if you spend all day doing anything in medicine, you're on the diagnostic end and internal medicine, you're a surgeon on the other end, basically you've got stuff to do at home too. Family stuff, you've got to run some errands. You're not going to spend all night reading medical journals. You guys are all familiar with the exponential curve. Okay, that's what medical knowledge is doing, it's exploding. Okay, so there's no way they can keep up at all. This is going to be essential. I don't care if it's Google in on this or any other set of companies. These foundation models are the only thing that's going to save us. And around the developed world, our healthcare is very hit and miss. Those of you who've had the disruptive class understand we don't have healthcare, we have sick care. Okay, that's our model. Eat, live, act any way you want till symptoms arise. That's what we do. Okay, so that's reactive, it's sick care, you have symptoms, blah, blah, blah. Okay, so they're talking about would it handle sensitive data such as medical records, personal details, and our preferences, etc. You better hope it does. My physician just went up to the Mayo and spent a week in Minneapolis, the Mayo.
I think it's
Rochester.
Florida and Maine.
Where's Mayo in North?
Maine?
You need to go to Jacksonville. No, somewhere in the Midwest. He spent a week up there, and the first question they asked him the first morning, he had a complete physical. They said, would you mind if we used MedPalm 2 to get together your data? He said, have at it. Then 20 minutes later, he called me. I said, go for it. But they asked for his permission to enter his data in MedPalm. So they're getting plenty of data, and that's fine. But my point is this. More than likely, when we get to AI agents, I want you to be thinking about these foundation models. Medical data is messy. Physician handwriting is beyond a fiasco. Drunk chickens do better than what they do. I mean, it's just awful. And a lot of them are proud of it. I'm a physician, here's my signatures, you know. So it's tough, but I've already started asking physicians, do you have an AI assistant? And at the moment, since my physician's retired, Lynn and I just switched, and the guy was, what? Why would I need one of those? So you guys keep this in mind, because my guess is within 5 years, before you guys are 30, AI assistants are going to be standard of care. It'll be the new standard of care. For the simple reason physicians can't keep up with this. So that's the sort of thing that I don't want you to lose track of, because it's a very interesting field, especially as you get older. It becomes a lot more interesting. And you guys are just happy campers right now, so this is good. So I wanted you to get a look at foundation models pretty closely before we moved all around. So we talked about MedPalm 2, clinical BERT, PubMed BERT, that's fine. Manufacturing legal, any of these things you guys can find that have more specific large language models, foundation models. Energy, that's an interesting space right there. We're in a huge alternate reality for energy. As you can imagine, you've got fossil fuels on the one hand, you've got renewable green energy on the other, and they're having to completely redo these foundation models. Do they redo them? No. They've got foundation models for fossil fuels, foundation models for green energy. So retail, naturally, standard. Insurance has become a nightmare. Munich Re is, of course, a reinsurer. Insurance models have completely blown up since first COVID, then the weather. So the climate models and the insurance models are now having to be merged. That's turned out to be complex. Supply chains, basically COVID showed us how wonky the supply chains get, how wobbly they get. So they're starting to factor in global health data, if you will. But it did completely change somewhat change the idea about what do we do about transportation logistics. We're moving our manufacturing back into the States, not fast enough, but for the geopolitical reasons. Construction, real estate, same thing. Construction's in a little trouble right now because they have enormous pushback. They still want to use bricks and sticks, their old tried and true supply chains with lumber, and 3D printing with concrete's coming on pretty strong. Agriculture's always been a leader. That's good with their foundation models. Telecommunications, straightforward. Hospitality, same thing. Again, as we talked about, they completely had a revolution with Airbnb. So then we get to education. I always put it last. You've got K-12 on the one side, you have higher education on the other. I've had numerous emails from students when you read the syllabus in this class for the first time. They said, we almost fell over that you said you got to have an account on GPT or Claude, and they were like, we've been told most of the time we can't use it. And I thought, well, that's kind of interesting. I don't really know how that would be, but we're in a mess. And EduBERT is a notice. It's a foundation law for educational text and curriculum design. I know you guys haven't used that. Some of us have taken a look at it because to change a curriculum here at Auburn, 5 years. And that is it's a nightmare in higher education. If you move down to K-12, you get to factor in politics. So that's turned out to be a problem. They do exhibit foundation model to have emergent capabilities, which is fine. GitHub using Microsoft Copilot, and what it did, this is a repository of code. It had unexpected emergent capabilities, and what they do, it started generating its own algorithms. That's kind of interesting because they weren't explicitly present in its training data, so they went right on in there. Design patterns, picked them up themselves. Then it adapted to company-specific coding styles. Now that's kind of interesting when you look at what it would have to factor in there to write code for a specific company. And then, of course, they were very happy. Microsoft had, software development tasks much faster. But basically, it came from those emergent capabilities. That was kind of surprising. Goldman Sachs, naturally, they have to handle a lot of documents. Now, know what they had. They were looking for call transcripts. You guys know when you talk to your advisors, your financial advisors, everything's recorded. It has to be. Legal reasons. Okay? So, notice what it did. It wasn't programmed in any way or prompted in any way to pick up emotional cues and executive language correlate with subsequent stock performance. My guess is executives get very emotional when they're worried about their stock performance. The 90-day thought mentality. Notice it picked up patterns and how they answered questions about misprojections. Well, if you come up short, it'd be kind of interesting to see how executives are going to handle that. Model was not developed to do that. Notice cross-reference statements across multiple quarters for consistency checks. That'd be real interesting if you're tap dancing. And of course, they had short-term market movement improvements. Well, the Mayo, this is tied into that MedPalm that we were just looking at. They have their own foundation model also, so they're running several up there. Notice what it did. Connecting symptoms across seemingly unrelated medical specialties. This is an edge case that the foundation model was picking up on. By the way, medical specialties, it's hard to get all those people together to talk about anything. You typically see that in morbidity mortality conferences. Morbidity, the patient's patient's sick. Mortality, they're having to explain why the patient passed away. And so you get a lot of medical specialists together. They have a lot of trouble with common language. Notice it was integrating information from radiology images and patient history. Notice this, that it was not explicitly trained on, which meant it was not fed data. So it's picking it up with deep learning. That's great for a foundation model, but it's fascinating because when this comes up, what do physicians say? Do they trust it? Not right away. Would you? By the way, suppose that you're in the physician's office and she's looking at you and you're at the Mayo and she points out that the system came up with information from your medical history and radiology images. In other words, it's giving you a diagnosis. How happy would you be? Now, we'll say this happened with my physician 2 weeks ago when he was at the Mayo. And he had MRIs, the usual. He had some CT scans and some x-rays, because he got what they call an executive physical. But what was interesting was they analyzed his hair. Okay, now, why would you get your hair analyzed? I'm talking about a real physical, guys. I'm not talking about how you feel. Why would you analyze your hair?
DNA. DNA.
Well, you're going to get DNA out of it there, but they got that from him already. They pull that out of his blood with the blood work. Good point. It is. You will get DNA. Y'all know how that works. They get the follicle. Okay. No, heavy metals. And I had not. I heard about that, but cadmium, lead, mercury, arsenic, heavy metals that we pick up in the environment. And so what they did, they had some of his images and what they found in his hair, and his team was correlating those things. Now, he's been a physician for 45 years, and that was a real interesting discussion. And then, of course, potential medication interactions. One of the hilarious things is any physician will tell you, if they get a patient over 70 coming in their office, what are they coming there with? A 1-gallon Ziploc bag full of meds. Because their patients are told, if you have more than one or two, bring them all in with you. You know, those little pill bottle things. Because they can't remember any of that, you know. And the physician we have now, Charles is retired, said average over 70, 12 bottles in the bag. Okay, now think about drug-drug interactions. Why would you have all those? Because you go to different physicians. So it's interesting, when you get that these drug-drug interactions are not directly covered in medical literature, that's scary in itself, but the system had to pick it up, that's even scarier. So really helped Mayo diagnose complex cases. What's a good example? Long COVID. You all know about long COVID? Okay, that's an extremely complex disease to diagnose. Inventory management. This is kind of fascinating when you look at this and you say, well, we've got to figure out what do we do about regional supply chain disruptions. What does the model do? It starts predicting those out of what look like unrelated news events. Kudos to Walmart for entering the news. I'm sure they're entering the weather as well. And you turn around and you say, that's pretty interesting. Would you believe it? You're the human guide, you're the business professional. That thing talks to you. Inventory reallocations based on weather, that's great. Seasonal purchasing pattern differing by geographic region, pretty interesting. If you're Walmart, are you doing anything about the cold snap we're having these 2 days? You can. Fortunately, it warms up on Wednesday, but you got to think. Document analysis for JP Morgan. Notice unsupervised pre-training. This is where they pull their data. Okay, pretty standard. Gave a broad understanding of financial language, which is great. Okay, so then they went to self-supervised, where they trained the model up. They started giving some fine tuning, and notice they were predicting mass financial terms. So what they did, they'd feed the earnings report to the system, and they would mask what the earnings report said and see if the system could come up with it. Complete partial financial statements, summaries, that's very helpful. You have to be very careful, though, as a human user, as a business professional, and then relationships between metrics. My guess is I'd really like to know if you come through a major in finance here or a master in finance, do you have that? Do you have that page and that page? I don't know. And then the initial fine tuning, label financial data sets naturally, Then they did it again because they needed specialized vocabulary. Okay, so they've got patterns in loan applications, credit agreements, regulatory filings. If I'm a human, I'm wondering how long I'm gonna have this job, and of course, industry-specific indicators. Now, that is kind of interesting when you look at these phrases. Exceed expectations, we're sure that's positive. Guidance adjustment being negative, you gotta be careful how you read those things. Notice what they did. Contract analysis, review, document review time, risk assessment, loan default prediction increased, and then customer service systems that can understand complex financial queries. By the way, if you're a human and you have a complex financial query at the moment, you do not want to talk to a chatbot. Okay, sorry about that. And they've made quite a bit of annual savings. Now, Lowe's is kind of interesting. What's the biggest problem at Lowe's? Finding a human in a red vest so you can ask a question. Okay, they've cut their staff, and it's like Walmart. Okay, so what they do? What they decided to do is do visual product search. So they did a vision transformer model, and they had all these, think of these data sets, product images, photographs, do-it-yourself project documentation. I'm sure they scraped this off the internet. Hardware component close-up photographs and instructional diagrams and schematics. Great idea. Somebody's doing some thinking there. All right, I've got to figure out, I'm going to pre-train it. So I got visual patterns, object relationships, spatial arrangements. Very cool. Then it demonstrates capabilities in general object recognition. Notice, feature extraction from photographs, and they were contextually understanding objects within environments based on, I'm sure, photographs. All right, they fine-tuned right away, and they had a labeled data set of 1.2 million home improvement images. Somebody's doing some thinking. Notice what was in the data set, all those product categories. Okay, so now I can understand home improvement, which is Lowe's mission, and similar product types, patterns across lighting conditions. I had not thought about that. That's pretty cool. And then categories items based on Lowe's product hiring. That's wonderful. Then they went to the second stage, and they decided to get more highly specialized data sets. Notice what they're looking for. They formed their Find My Item visual search tool. Now, 8,500 customer submitted photos. That's good. Home repair, parts, components, and then notice that system can decide new, worn, or damaged. And then they had images in real world settings rather than in a catalog. Okay, we're still working on this. I want to do part recognition, condition assessment, contextual recognition. This is second fine tuning. Now, I can identify plumbing components, even when partially visible or installed. Comparable replacement parts for discontinued items, matching hardware items to products in the inventory. Reduction in return rates. Successful first-time purchases. These are great improvements. Decrease in customer service calls. Now, you've got a great foundation model to give you those results. Obviously, they're going to port that onto a phone. You go into a store, you enter what you're looking for, some type of screwdriver, or take a picture of it, or it gives you an image, and then you walk to it. What would you have inside the store? You'd have a nav package. Okay, a lot of business applications. Got all sorts of generative AI in accounting. Now notice, that's PricewaterhouseCoopers. Accounting has tax, audit, mergers, acquisitions, and research, etc. And so I've got to do anomaly detection, auditing expense claims, all this kind of stuff. I've got all these functions. I've got finance going through the models, just like you would expect. Notice what they're doing. Traditional models for market risk. HR at Unilever. and their models, candidate screening and retention. Supply chain, we've been over. P&G. Analytics, of course, underlies all this. And you've got architecture, construction, healthcare, we've talked about, and so forth. So I run through all these and I say, all right, so that's just strictly with product design and prototyping. You can imagine what the automakers are doing. Cleveland Clinic, I mentioned this because they have done a good job trying to figure out how to get patients manage their own health care. This is a real problem. And so they do have a chatbot that handles really the 80-20, they're on the 80%. Appointment scheduling, medication reminders, and symptom assessment. Here's the problem. Scheduling and medication reminders are working fine. That's not. Symptom assessment, how many of us do a real good job describing symptoms? I mean, really. When I was a dentist, the worst thing that could happen was you come in and say, what's on an emergency call? I say, what's the problem? Well, I got this pain. You go, it's going to be a long afternoon. So that is not done particularly well. The system will listen to what the patient says, natural language processing, and it does have their medical history on board, but I will tell you now, that requires a human to talk to the human. But we're trying. We're giving it a go. Now, this is great to see. My chest feels tight when I breathe deeply. Well, what in the world? You could have a COVID, you could have the flu, you could be having a heart attack, you could have an aortic aneurysm, et cetera, et cetera. So they are giving it a go. It is not done well. The Bank of Montreal decided to put in this assistant, that's fine. What do you run into? Account inquiries, straightforward, transaction analyses, did my check clear, that's fine. What is this? What's Bank of Montreal's liability with financial planning guidance through a chatbot? I would not want to be responsible for that. I'm sure the legal people are really having an interesting question on that one. It does do a great job explaining things if the question's straightforward enough. It has reduced call center volume, that's fine. Okay, industry verticals, you've got all sorts of things going on, and I put this in there because I want y'all to think that it's not fairly specific foundation models for what we're doing here. Manufacturing, industrial electronics, that's understandable. Retail consumer goods, finance and banking we've talked about. Accounting, can't say enough about accounting. By the way, I asked my 3 Master of Accountancy students this morning. They all have jobs already. And I said, are you guys being asked at all about machine learning? Oh, yeah. What do you tell them? Well, we don't know anything. We didn't get anything. Master of Accountancy program. They've all got CPA designation already. They're brilliant. But my question is, what are you going to run into in the real world? What they're going to tell you is, well, so you don't have anything, you go out to Udacity or Udemy and go pick it up. So that's where they're heading for. Hospitality and traveling, that's great. How'd you like to be in that field today? With Thanksgiving coming up and no airplanes. Healthcare, life sciences, okay, great. Customer services, everybody wants to get rid of call centers. I'm not sure it's a good idea, but people are really putting some money into chatbots. They're trying, let's put it that way. Advertising and sales, naturally, one-to-one marketing. Okay. Because this is hitting home so hard to everybody in K-12, this is what the marketing people would really like to say about generative AI in education. It benefits teachers and administrators, et cetera, et cetera. We've been over this, we'll go over it again, but it is very questionable as to whether or not with students I'm destroying their cognitive processing, including the teachers. And so I'm just not sure. This looks to me like K-12. And so we're still having that debate. Fashion, okay, I'm fine there as far as image. Entertainment and gaming. By all means, let's put more of our teenage boys on video games. So the real problem here is they're getting a whole lot better. Better graphics, better action, etc. Media. Okay. Generative AI has really upset media because, as you know, so many articles are being written all by generative AI without enough human input, and you've got all this kind of stuff here, generating interview questions, story ideas, and social media headline. So we've got this problem going on. Every now and then you'll see. I know Sports Illustrated ran into that. You just don't know who's writing this stuff, whether it's human or generative AI. HR is square in the middle of what are you doing about hiring, upskilling, reskilling, lifelong learning, et cetera, et cetera. You really want to have a talent life cycle over the lifetime of the employee, et cetera. And so it's interesting. There are assistants that let you look at your career path. This is fine. I think it'd be great to have a mentor as opposed to a human mentor. There is a boatload of work here. HR is very, very legal. Just like we have legal services, generative AI is getting lawyers fired, as you guys know. It is getting them disbarred and fired off cases. It is a disaster for lawyers who are using it without checking hallucinations. I do think for electronic discovery, generative AI is outstanding, as long as you back check it. As you know, we're right in the middle of a fiasco in computer science majors in colleges because of software development. Whether or not we actually need coders anymore, the answer is yes, we do. But there's a lot of work, and you guys have done that this semester. So the question is, we've already got coders using these tools, and I think the question is, are they doing enough on the front end to be able to check the results on the back end? And that's turned out to be a problem. Let's talk about automotive on Wednesday, because that's autonomous cars, okay? Let's see you all.